Okay, hello, and welcome to this eSchool News webinar, Smart Building Implementations for Education Facilities. My name is Kevin Hogan. I am the Content Director for eSchool News, and I am happy you are joining us today for what I know will be a very insightful and important conversation. This event is brought to you by Honeywell. Honeywell Building Technologies is transforming the way every building operates to help improve the quality of life. They are a leading building controls company with operations in more than 75 countries and supported by a global channel partner network. Commercial building owners and operators use their hardware, software, and analytics to help create safer, more sustainable, and productive facilities. Their solutions and services are used in more than 10 million buildings worldwide. Now, before we get to our conversation, I'd like to take a minute to go over some of the features of the platform that we're using for the webinar. This event is being recorded, so you don't have to worry about missing a thing. Within a few days, you'll receive an email message that contains a link to the recorded webinar, along with a PDF of the slides. If you have a question or comment, there is a chat function that you can launch. Feel free to use this feature to contact someone from the eSchool News team if you have a technical question. But also, if you have a question or a comment for Joe, I highly encourage you to use this chat function as it helps us drive the conversation to where you want it to go. So now, with these housekeeping items out of the way, let's get started with our conversation and our introduction to Joe. Joe Chapin is the Business Development Manager for the Education Vertical at Honeywell. He joined the company in 2019 with roles of both engineering and sales. He holds a bachelor's degree in business from the University of Oregon, go Ducks, and a master's in telecommunications project management from Stevens University. With that, Joe, I'll pass it over to you to give us some of your insights and ideas.
Okay, I'm going to go ahead and thanks for the introduction. I'm going to share my screen here. Okay, can you see the screen?
Got it.
Okay, great. Thanks for joining, everyone. Here's our agenda for today. We're going to talk about sustainability, talk about air quality, why that matters, why a smart building, look at some IP networks, Internet of Things, and the global network, IP-based controllers, what's the advantage with those. We'll talk about T1L, which is 10 megabit service over existing 2-wire. And we're going to look at balancing regulatory requirements and operational needs, finish up with IAQ, and look at some building automation in the form of Niagara. So I'll go ahead and get started. So what are the ongoing challenges in sustainability? Well, you've got changing regulations for one. Those are constantly changing, being upgraded. Uncertain pandemic circumstances. You have inefficient operations and downtime. Carbon reduction strategies. A lot of companies now, and schools for that matter, looking at ways to reduce their carbon footprint. You want to also be aware of the tax incentives that are available now for the government to implement strategic upgrades to your facility in the form of building automation. You want to maintain the competitive advantage, of course, minimizing absenteeism, excuse me. You want to make the environment better and more efficient to attract students and staff. And then also, of course, maintaining profitability in schools, not so much profitability, more about efficient operations and energy savings. So sustainability is a key issue with education, the education system, and it's a multifaceted way to look at that. So 3 different areas I want to look at here. Give me 1 second here to minimize that. There we go. Efficiency of cost. According to the EPA, 25% or about $2 billion worth of energy is wasted every year in U.S. schools. And then you look at the resiliency and the center tile there, the risks. So you want to have people involved with green school construction, green school initiatives. Putting a building automation system in place can assist with that. And of course, like I mentioned previously, you can reduce absenteeism and improve your student performance based on the air quality and the environment in which they go to school. Also, you're looking at equity, of course. Reports are showing children of color and low-income students disproportionately attend under-resourced schools, or educational environments were the least conducive to learning. Put a building automation system in place, you're able to raise the level and the quality of those schools in general across the board. And so you want to also think of equity in this particular case. Air quality does matter, and it's no more prevalent than now after the pandemic that we had. I don't think I'm understating things when I say the pandemic changed everything and brought IAQ, indoor air quality, to the forefront. And so you want to have adequate fresh air exchange, of course. You want to maintain proper climate. That includes humidity, that includes testing for TVOCs, organic compounds, CO2 levels, of course. For those of you that live in either a very dry or very wet climate, you're going to look at humidity levels as well. That obviously, monitoring and controlling humidity levels is very important. For comfort, you want to be able to access your HVAC data without disruptive or expensive upgrades. So one of the key things I mentioned a couple slides ago was the T1L, which is the 10 megabit over existing 2-wire. The optimizer controller we have is the only controller on the market right now that has the ability to use T1L. What does that mean? If I can reuse existing wiring, that means I don't have to place new cables. So those schools that were out of reach for upgrades at a certain point, now that you have this controller option, take away the cost of placing newer cables, you could bump your school into a new era where you're able to make those changes without the cost that you thought you would be, a lot less money to install said service. And then, of course, you can also look at taking your facility to the cloud with a remote building manager. What that means is you can take and connect your facilities, whether it's one or multiple, connect it to via the internet to the cloud. You can get a holistic view where you can monitor, watch, reduce, and automate all of your facilities from a single pane of glass. This can be as simple as using a smartphone or a tablet to do so. Last thing I'll talk about is, of course, room pressurization. With the pandemic, the pressurization of a room is important, whether it's negative or positive. Take a sick room in a school, for example. You want negative pressurization. I walk into that room, all the air goes up into the return, does not escape out of the room itself, so it contains the air in that room if anybody is sick. So I get this question a lot. Well, Joe, why do I want to do a smart building? What's the point? Well, I boiled it down to 9. These are by no means all inclusive, but for one, you're building for the future. You're putting the next generation of controllers into your facility. You're turning your facility into essentially a large computer. It is centralized control of a distributed system. The third tile on the right, you want to look at what's called an open system. Honeywell has a software service that is called Niagara. Niagara is an open system, meaning when I put a Niagara system in place of my facility, it's software. Think of it as the Microsoft Windows for building software. I now have the ability to have an open system, meaning I'm not locked into a single vendor. I can choose from multiple contractors who are Niagara certified to work on my system, meaning I get competitive bids. If I don't like the service I'm getting from contractor A, I can look contractor B. So Niagara, open system. Of course, when I say open system, I also talk about system integration. The number one question or concern that I get from customers is system integration. What they tell me is I've got HVAC on one system, I've got fire on a second system, I have elevators on a third, I've got video on a fourth, security, and they say all of the systems are separate, none of them talk to each other. How do I integrate the systems under one centralized control? Niagara is how you do it. It is the umbrella system bringing all systems together. So when you do that, you look at the tile in the center, you get to facility optimization. You can do things like static pressure reset, optimum start, in addition to many other things to overall, when the system is connected under one system, you have all of them working in conjunction together to optimize the facility as best possible. Also, when you're connecting to a high-speed network with our controllers, and in some cases our controllers can do 1 gigabit, that's 1,000 megabits, you get real-time information. You get HD video on top of security, on top of HVAC, all in the same system, all with no or little or no slowdown because of the bandwidth that you're taking advantage of. It also leads to stuff like predictive maintenance. One example of that is our system will keep track of the number of actuations on an actuator, and it'll keep track of that and tell you when it's getting to the end of its guaranteed life. It'll send you a notification saying you may want to go check actuator X or piece of equipment X. It's getting to that point, go check on it. And so again, you go from reactive maintenance to a predictive maintenance model. And of course, you have energy management. I can track water usage. I can track HVAC heating and cooling. I can track electricity. So all the things you can have in front of you, all being tracked and watched and giving you real-time information on what's being used and where the problem may be. And then also, of course, it leads to your ESG score. You get a smart building that's connected that reduces energy. Your environmental, social governance is also affected as well. So there are 3 different components of a smart facility. At the very top, you'll see a network. When I'm talking about networks, I'm talking about a high-speed network, whether it's your T1L at 10 megabit or it's your IP-based controllers, or it's wireless. The days of connecting to the backnet where your standard typical speed is around 80 so kilobits, you still can connect to those, but with the other availability of fast networks, you want to get to the high-speed network because of all the advantages. Number two, you got to have the hardware. These are the devices that connect to that high-speed network. You have your controllers, you have your security cameras, you've got your actuators, all the different components that are connected to a single network under one. And the third thing, of course, is your software and your cybersecurity. Besides the question of integration, the second question I get is if I'm connecting my facility to the internet, I'm afraid of hackers. I'm afraid of what they're going to do. And so what we tell them is when we have the Niagara system installed and in place, we have the cybersecurity built into the Niagara platform. It is in the form of a FIPS 140.2 level compliance, which is that stands for the Federal Information Processing Standard, that it's some of the highest cybersecurity available. So again, that is built in and taken care of with the Niagara system. Now, IP networks, Internet Protocol networks, that is the standard language of the internet. And here's why IP controllers, one of the main reasons why they're so much more desirable than your standard controllers. So if you look at your standard operational technology, BACnet, Modbus, FOX/FOXS, they typically run around 78 to 80 kilobit. That's about the internet speed of 1995. Okay, so if you're on one of those connections, it's like you're surfing the net from a 1995 internet connection. When you install an IP-based controller that has the ability to connect to your Category 5 Ethernet cabling, you go to 1 gigabit. What that means is you now went from a one-lane highway at 78 kilobits to a 12,800 plus lane highway with your 1 gigabit. This graphic really doesn't do it justice, but essentially you're going from your snail pace to your light speed pace by installing a new type of controller. And you do that with the IP-based controller shown in the center. That's one example. So if you look at your standard OT architecture, this is what it looks like. You have your switch at the top left, you have your standard Jace, and then you have all your different yellow lines representing your connections, whether it's Modbus, BACnet. This model works fine. It's worked for many, many years without any problem. All your connected parts connect great. Two problems with it. Number one, if one of these lines is cut, anything downstream is going to go offline. You have what's called a collapse ring, meaning no ring at all. So this is how it has been for the longest time, and it's worked fairly well. Now, if you look at a standard IT architecture, this is your standard computer network. It looks pretty similar if you look at the two. So let me go back a slide. Here's your OT architecture, switches at the top left. Here's your IT architecture. The router and switches are on the left-hand side. So the architecture is similar, but here's the big difference. The speed, 1 gigabit, 12,800 lanes versus single lane. So what we have done with these IP-based controllers is we have put our controllers into this IP-based network and taken advantage of the IT-based network. Also notice that the controllers are put in a ring configuration, meaning they have two connections. One link gets cut, another link cuts over and takes over in this form, what's called rapid spanning tree protocol built into the device itself. So we took and we went to get to the IT networks, put our controllers in there. Now they have the best of both worlds, high speed, redundant connectivity, full access, full stack Niagara, cybersecurity all built in to a network that you most likely have in place already. I have yet to see an educational facility that does not have some type of Cat5 network in place. So here's a very busy slide. Let me point this out. If you look on the left-hand side under where it says Ethernet LAN, that was 2 slides ago. This is your standard typical on the left-hand side. You've got your controller, you've got your Jace. Again, worked great. If you look over here under where it says firewall and Niagara 4, that particular cluster, that is what the slide was just previously when it's connected to the IT-based network, ring configuration. The blue jagged line on the left-hand side that jogs over, what that's showing you is with these controllers, not only can I connect to the IT network, the high-speed computer network, I also have I/O modules that can bring in your BACnet, your Modbus. What does that mean? I can cut over legacy systems without placing new cable if I don't need to. Again, it's going to be slow at that particular link, but what this does, it gives you the flexibility to have both the IT and the OT on the same network with built-in cybersecurity, and you're consolidating and bringing all of it under Niagara, the umbrella system. So again, left-hand side is where we were. Under where it says firewalls, where we are now, the blue line indicates cutting over legacy systems. So I can do a graduated upgrade of a system, and then I don't have to do a complete slash and replace of all the cabling if I choose not to. And don't forget, we also have the T1L where I can reuse existing and bump up my speed from 80 kilobits to 10 megabits. So that's a lot you can do. So if you look at the controllers that have the ability with the T1L, these are the three we have on the left-hand side. This is your optimizer advanced controller. In the center, you have the optimizer unitary, and on the right, we have our Spider 7 VAV with a built-in actuator and wireless capability. All of these have Niagara built in. They all have various communication methods, Wi-Fi, Bluetooth, your I/O modules on the top and bottom, IT, and don't forget T1L as well. These are the three lead controllers we have right now that do all the capabilities that you need to upgrade a system at a minimal cost. You're also getting advanced cybersecurity and full stack Niagara built in. Full stack meaning a fully functional version of Niagara system. So here's the kind of the bells and whistles of the optimizer system. It's great for sustainability and lowering operating costs. You have, again, cybersecurity built in, easy to install. You can achieve energy savings, and you can recoup the investment, whether you're saving on cabling or you're doing energy management. You can optimize your systems, again, open system, and then you have a facility energy management protocols built in that we can work on as well, where you can track and monitor energy, water usage, gas usage, so on and so forth. So again, a very great functional device that can straddle all the different types of networks that are available. Incredible option for upgrading your facility. So let me talk briefly about T1L. T1L is not a Honeywell standard and or product. It is an IEEE standard that's been around since 2019. And what T1L is, again, 10 megabits over 2 wires, we can go up to 300 meters between controllers with T1L. That means if I have an approved 2 wires circuit from A to B, I can go up to 300 meters without a controller. So again, 10 megabit single twisted pair. The Belden specs they're right there in the red on the top right. In some cases, you can go up to a kilometer between devices. We have a T1L adapter. If I have a very long run up to a kilometer, I can go and put that in and achieve more than 300 meters. I can almost basically triple my distance without having a controller. And again, 300 meters in a building is a long way to go. But for those times that you don't have that, you have this ability. So again, remember T1L, remember reuse existing wiring, remember not placing new cabling, and remember we've got the controller that can do that, several controllers for that matter. This is the T1L media adapter. This will allow you to extend it 1,000 meters between devices. So if it's a lot of facilities, I know sometimes they have an outbuilding that they want to get connectivity to, and they have a long 2-wire circuit. This is how you do it. So if you can't go 300 meters between the controllers, you can go up to 1,000 meters with this device here. So this, again, either Cat5 or T1L twisted pair. This one here, this shows you how easy it is to simplify. Again, it's an open protocol. You get 10 times the bandwidth. You can upgrade, reuse existing cabling. The very top, the dash line, what that's indicating is that's indicating a long stretch using the adapter. Below that, you'll see the adapter. What it'll do is it'll convert a category 5 to T1L via the adapter. Then it'll send it to each controller where you have 300 meters between each controller. At each controller point, you have multiple options for connectivity. You got BACnet, you got Modbus, you got Bluetooth. You've got ways to integrate all the communication methods into one consolidating controller by using the T1L. And again, 80 kilobits to 10 megabits, that may not be 1 gigabit, but that's still a ton of bandwidth when it comes to a building operation system when you make that leap. So this is a little closer look at our Spider 7 VAV. This has a built-in actuator. It has Bluetooth. It has the I/O modules on the left and the right-hand side. It does have T1L capability. Fully programmable, 7 universal inputs, 5 solid-state relays. It also supports Silk, Modbus. It'll install on both square and round ducts. A very, very good form factor on this device. You can see here on the left-hand side what they've done is they put a Spider 7 VAV, and they've picked up analog devices. They picked up Silk Bus. They picked up Modbus. You also have Bluetooth as well. And over here on the left, you see it downstream of a Jace again. So the point is, very small device, built-in actuator, T1L capability, and it has the ability to bring multiple devices together. The other really good benefit about this, this shows you kind of in more detail what this has. Modbus here, inputs, your Silk. You also can balance it wirelessly. So what that means is what I can do is I can put the device, plug it into my Niagara workbench, write my control sequence on the original device, install the device. I can test and balance it via the mobile app or the PC if I want to. Again, that could be wireless if you want to. Then I can take and I can clone and send out the control sequence to all the subsequent devices once I do that. So think of the amount of time you're going to save having to the old way of plugging into each device of the laptop to now I can do one device and send it out to multiple devices and clone it. This also works for upgrades as well. So very great functional device, and the built-in actuator is kind of the cherry on top of that. This shows you the overall optimizer architecture. On the left-hand side, you've got your advanced controller. You go up to the right here where it says BACnet IP. The top, they're taking a T1L media adapter. I'm looking at the purple line. They're sending this 1,000 meters to the first controller, and they're going 300 meters between controllers after that. You also have the ability where it says BACnet IP in the center. That's category 5 cabling, not necessarily T1L, twisted wire cabling. So you have all these different communication options. What this does is this simplifies your network architecture. The backbones are T1L or BACnet IP. All the devices downstream of the controllers, depending on what communication method is, you have all the flexibility that you want to bring it into one device and backhaul it up to the BACnet IP device via T1L or your category 5 cabling. So a lot of things you can do here. So in this case, what this is showing you, I have multiple different networks to start with. I implement the optimizer and I simplify the network. What it's also showing you is on the right-hand side, I've got my BMS system, just building management. But then if you go up and you look at the symbol of the woman there, that indicates the Niagara system. And what they've done is they brought in fire, they brought in CCTV, they brought in security, and then vertical transportation, which is elevators. And so all this is brought in, all this is watched and monitored under a single system when you use the Niagara system in place. Demand control ventilation, that's another thing you can do. So we have a couple different devices here. For those who don't know, demand control ventilation is, as the name suggests, depending on the number of people and CO2 in a room, it will bring in the amount of fresh air. This can be automated. So more people in a room, CO2 level goes up. I say, okay, system, if the CO2 level is going above my threshold, bring in more fresh air to bring the CO2 level down, and it works in the opposite fact. So what you do is you have a simple CO2 sensor on the left here, the 7233, or you have a multi-sensor that will do CO2, TVOC, humidity, temperature. So you can do either a single sensor or a multi-sensor. Below this, you have your TC500, and I'll go over these in more detail in subsequent slides. And so this will give you a readout. This is a touchscreen, small commercial thermostat that will also work for school buildings as well. And then, of course, the other thing we talk about is our variable frequency drives. These are devices that attach to motors, whether they're fans or pumps. And instead of having a 100% on or off, it can go anywhere from 0 to 100%, and you can vary the speed of a fan or pump, and it save a ton of energy with your VFD drives, variable frequency drives. So that's another part of the strategy for energy savings. Again, modulate the fan speed of these devices itself, and then you couple it with a building automation system, and you can match changing conditions. In a lot of cases, you don't need 100% fan capacity. Sometimes 25 to 30% will do. So imagine over time, if I'm running my fans at only 25% capacity, the energy savings that can really stack up when it comes to using that. So VFDs are a key part of the strategy, and these are also connected to the BMS system. School building management. The other thing we have here is we have this software package where you connect one or multiple facilities and you can get remote control and monitoring, again, from a tablet, from a smartphone. You can have real-time details about the comfort, the energy, alarms if something breaks or the temperature or humidity goes way out of your threshold. It'll send you an alarm and ask what you need to do. In a lot of cases, you can fix that problem by not necessarily being on site. You can do scheduling, you can do alarms. If you're going to have a week off of school where you want to shut down everything, whether it's the heating or cooling, you can do that all from the phone. You don't have to be on the system itself. So again, completely connected system, all the different components connected, all in front of you in a tablet or a phone, and all automated, giving you real-time readouts. And so you can take it the next step too, where you have different services that will look and monitor and watch your facility to look for key ways to save energy in your system, make suggestions. And this also does take into account climate. Say, for example, somebody in Phoenix is not going to have the same needs as somebody in, say, Louisiana or somebody in Minnesota, depending on the time of year. One of the things I got a kick out of was one time when the pandemic hit, ASHRAE recommended 100% outdoor air brought in all the time to make the air low CO2 levels. Well, that's great if you're at Los Angeles in January, but imagine being January in St. Paul, Minnesota, or say January in Minneapolis, somewhere cold. It's going to be a bit different. So these systems do take that into account, existing outdoor air conditions when they do this. Features and benefits of this, of course, it's easy to install. You install a gateway, connects to the cloud. Niagara's installed, it automates and gets all the points. Pretty cost effective. There's no upfront charges really, just no need to manage IT. Very simple to install. It's scalable. If I want one facility or I want 100 facilities, you can do that. It's easy to onboard other cloud services that we have. So you start with the gateway, the connectivity, and then you can add other services that will do things for you as far as remote monitoring and triaging of problems if you need it. And of course, you have uptime. We have people 24 hours a day, different call centers around the world that will watch your facility when you are not able to watch it. And a lot of times we can fix the problem before we have to roll a truck crew to do that. So again, just the different things you can do when you implement a smart facility. This is the software portion of it where the service really comes into play. So this shows you how building manager works. On the left-hand side, you got your Niagara supervisor that can connect to the cloud. And this cloud is called Honeywell Forge. Downstream of the Niagara supervisor, you got different plant controllers. The red dots are looking at lighting, they're looking at metering, temperature, humidity, fan coils, so on and so forth. You also on the right, we have for some of the facilities, you can do what's called a smart gateway. And here we have a LoRaWAN hub, we have your TC500 thermostat, smart IO. Again, this shows you how it all connects together. It's a really easy way to do that, but the connectivity is the key part, and the connectivity to the building manager is also the key part. So remote building manager, remote connectivity for your facility that you can use and watch. So let's talk briefly about one of the sensors that was on the slide before. This is our TR50 IAQ sensor. You can do humidity, temperature, particulate matter, VOC, and there's two different flavors for this. So let me talk about the two flavors. Over on the right-hand side, you have the 5-in-1 sensor, PM 2.5, that's particulate matter 2.5, CO2, total volatile organic compounds, temperature and humidity. Or you have a 3-in-1 version, which is CO2, temperature, and humidity. So this is a single device that'll do multi-sensors, different parameters you can read out, connect to a building system. Again, BACnet, MSTP, Modbus, so multiple communication methods for flexibility. It's got two different flavors when it comes to the display. On below, you have the display where you see the numbers. On the top, there are no numbers without a display. Green is good, yellow is take action, red is bad. And so it'll show you the different parameters. You have a slide bar at the top. So again, very simple device, very easy to use and very easy to see what's going on, red, yellow, or green. Pretty simple universal colors to show what your system is doing. This is just driving the point home. On the left-hand side, you got the two options where you have 3-in-1, temperature, humidity, and CO2, or the 5-in-1, which will add particulate matter 2.5, that's particulate in the air, and TVOC. TVOC is a good one because I'm sure some of the people who are in educational facilities are aware of that one classroom that every day about 2:30 or 3, the one classroom that gets fumed out from the buses idling for the pickup for the kids. One of the solutions we have implemented is you put a TVOC sensor in the air intake. And once it started sensing the fumes coming into that room, it shut the outside damper and brought air from the other side. This is all done automatically, by the way, via a control sequence. So they eliminated the problem of that particular room with the bus fumes. This can be, metal shop, things of that nature as well. So again, a lot of things you can do with this when it's connected. By itself, it's a great unit, but also connecting it, you can build in the automation as well. A lot of things you can do. So you're transforming your air quality into student comfort. So better indoor air quality can provide significant benefits for educational spaces. So CO2 data can optimize ventilation. It can self-calibrate with this device here, and your threshold can be whatever limit you want, 1,100 parts per million. It can have a readout where you see here is 1,140 if you want, when the red dot indicates that's not good. But it's also very easy to integrate into an existing system. Again, remember, when you put a Niagara system in place and you connect one of these devices, it automatically goes in discovery mode and picks up the devices and brings it in and identifies it. This is our TC500 thermostat. Very simple device, touch screen, slide up and down. This particular device here on the front is showing you the humidity level is 48%. It is occupied. It is 66 degrees. They're setting it to 68. And the yellow flame indicates it's going to heating mode. So this is, I'm going to just touch on a couple of the points here. Three-stage heating and cooling, good for air handlers and rooftop units and heat pump systems, which are coming back into fashion, so to speak, with energy savings. You have a setup wizard that will cut the installation time. You also have a contractor wizard. These have been very popular for some military housing for a couple of reasons. Number one, it's very easy to integrate and install, connect via Bluetooth, Wi-Fi BACnet, or Silk. You have a homeowner or unit owner app where you can do the scheduling on your phone for this device. In addition to that, the contractors have a device where an app where they can set it up to via Bluetooth to program the device itself. So this device by itself can connect to a CO2 sensor in a unit, provide a very small building management system for a single unit. Or you can connect multiple ones of these TC500s to a centralized device for centralized control. So it's very flexible that way. On the left-hand side, this just shows you how it looks. Current temperature, system mode is heat. If it's cooling, it's going to be the snowflake here. And then, of course, we have delta T monitoring. It tells you the discharge air temperature, mixed air. Delta T basically is showing when if there's something off on your system. For those who don't know, it's another feature we built in to make sure the system is running properly. But again, real-time information with the delta T. And if you look at the right, you can see that's the contractor app, and they can go in there and they can tweak and figure out to make sure it works the best, all via the Bluetooth. Pressure sensors are another part of the strategy. Negative pressurization in a sick room. Again, I walk into the room itself, all the air goes out through the exchange, or no air leaks into the hallway. That would be a negative pressurization situation. Second thing is a positive pressurization. That would be for telco rooms in a lot of cases. So I would install negative pressurization systems in sick rooms, maybe wood and metal shop, auto shops where there would be fumes, maybe some art rooms where they may be using paint, things of that nature. So again, negative pressurization, you see more of that than positive in a lot of cases. You'll see positive pressurization in data centers, but the point is, if I put these air pressure sensors in place, I can control the pressure and control the airflow of a room that best suits my needs. So again, air pressure sensors are another connected option that you can do with your facility itself. So a lot of people ask me, well, why do I want to specify Niagara? What's the point? Why do I want to do that? Well, number one is the compatibility. Niagara is an open system. Again, multiple contractors. I can have competitive products or existing products that work and talk via a standard open protocol, BACnet, Modbus. I go in, I put a Niagara system over the top of that. They will go into the Niagara system and they will pick it off and go into discovery mode and put the points together and build out the system itself. Its risk mitigation, of course, is very important. We have the highest levels of security available, built in, provided by the Niagara system. Cost savings in the form of getting competitive bids from different providers. You're no longer locked into a single contractor for system X. We support multiple systems. And then, of course, it's flexibility. Like I said before, multiple systems are supported. So the key thing to remember about Niagara is open system, built-in cybersecurity, constant upgrades, most flexible system available. In a general sense, there are 4 different areas. Of course, you do HVAC, you have safety and access can be brought into Niagara, lighting, power, and water. All those can be brought in to watch and monitor. Then, of course, you can go as far as you want with people counting, people detecting. So the thing about Niagara is we are always adding new drivers, new abilities every year to bring it into a centralized system. If you want to get a little more granular, these are all the different areas to which Niagara can integrate into one system. As you can see here, you got lighting, you got HVAC, metering, power metering, gas, water, electric, safety, sensors, you name it. And so there is no more open or inclusive system when it comes to building management than Niagara on the market that we are aware of. Here's an example of some of the analytics. In this case, you've got your air quality on the left-hand side, picture of the building itself. We're looking at floor number 1. If you look over to the right, you have a mock-up of floor number 1. You have all the air handlers and their temperatures. You have all the different zones with different colors. If this were a clickable, it's not in this case, obviously, as a slide, but you can look at humidity, look at CO2. Again, keep in mind, you set it up the right way. You can have this done on a tablet as well. You don't have to be on site. If you want to look at a specific building, here's an example of a building itself. On the left-hand side, you got home, you have alarms, you have your history, your schedules. Looking towards the center, my entire building averages 43% occupied. To the right, 86% are in the zone of comfort, and we've used 173 kilowatts so far. Below that, you're going to see average temp, average humidity, again, for the entire building. And then you have all your zones, lighting zones, active zones, so on and so forth. On the right, I have the ability to click and look at my cooling tower, excuse me, my chillers, my air handlers, my hot water and chilled water systems. If I want to go down to a specific floor in a little more detail, this is the floor number 10. On the left-hand side, all the average temperatures by zone, they're color-coded. On the right, like before, air handlers, VAVs, average temperature. And again, you can click on all these and you can look and get a mock-up of the specific VAV if you want, like this, if you want a three-hand. This is, I believe it's an air handler here. So in this case, you can bring this up and look at it. I don't see this type of implementation done very often when it comes to graphics, but wanted to show you what the possibilities are with the graphics. More often than not, it gets to this point, you hit the click on the VAV and it'll pull up and give you kind of a readout of what all the specifics are on that particular VAV or air handler. So let's look at what you would do with the school. One of the questions I get asked a lot is, what's the best way to start with this? And this, in a general sense, kind of shows you what a typical school would look like. So on the left, you have the school administration building. They're looking at the ASHRAE parameters. They're looking at a healthy building dashboard, looking at the remote building manager. You want to do a facility audit to start with. What do you have? What kind of system do you have? Is it an old pneumatic system? Is it more modern? And then what kind of connectivity do you have? But this is showing you here is the different areas. You look at the top, I've got MERV 13 filters. I've got PM 2.5. I have CO2 sensors in key specific areas. I'm looking at pressurization. So you want to look at all the different parts of your system. Where can you connect? Where would it make the most sense to have CO2 sensors? Do you have a requirement by the government to have a CO2 sensor? I believe in California, there is a requirement for every classroom to have a system or a CO2 sensor in place. But this just shows you in a general sense what it would look like in practice when it comes to doing a school and a building. So predictive maintenance, we touch on that real briefly. What it does is it determines the condition of an in-service equipment in order to estimate when maintenance should be performed. So what it does is it looks at routine-based maintenance you've done in the past, and it goes into a predictive model. It looks at actuators, it looks at air filters where it will sense pressure drop, meaning this filter is clogged, needs replacement, and it helps with your HVAC maintenance. And so most predictive maintenance is performed while equipment is operating normally to minimize disruption. And so it's going to maximize your investments. It's going to eliminate unnecessary plant replacement. And it's also going to take the guesswork out of maintenance when you do this. So when you go from reactive to predictive, more often than not, it does translate to savings, whether it's time savings and or money when it comes to predictive maintenance. So this monitors and watches your system when it comes to a predictive maintenance model. One of the things you can implement with a smart building is what's called optimum start. What that means is I want the temperature to be 72 degrees by the time I walk in the morning at 8 o'clock. Well, before, with a not so smart system, you would go in there, you get there in the morning, or the maintenance person would get there 2 hours before and turn the thermostat up. What this will do, it'll implement a control sequence to number two. It'll do two things. If you look at the top right, you have a normal thermostat in red where you have the ups and downs of turning it up and down manually via the day. What you're doing, if you move up to where it says HVAC controller, I can even out those highs and lows, which translates to savings. So what I'm going to say here on the bottom right is, okay, if I want to be at 9 o'clock and be a certain temperature, I'm going to start the system at 6 o'clock. Keep in mind, when you have this in place, it takes into account the outdoor air temperature as well. So it could be heating, could be cooling, could be increased or lowered humidity. You can do humidity, you can do CO2 levels. All of these things can be implemented. It's not just temperature, it can be other things as well. And so really, this is a great way to make the system as optimal as you possibly can. This is, again, optimum start. The other thing you can do, there's a lot of words on this slide. Let me just put it this way. Static pressure reset. What static pressure reset is, it's determining the amount of air pressure needed to get to the end of the system, the furthest point, to make the system work properly. A lot of times, the static pressure in a building is set higher than it needs to be. And so what this will do, if you put pressure sensors in place, this will recalculate the amount of static pressure needed to get your system optimally set. And so instead of having to take the guesswork out of this, I can say I want my static pressure to be X, and it resets that and it adjusts the VAV boxes to make sure the pressure is working the most optimal way. Again, it could translate to energy savings with static pressure reset. Just a couple of examples. So there's three different types of controllers we have. On the left-hand side, you have your IP-based controllers. These are your 1 gig controllers that have the ability to incorporate multiple. In the middle, you have your Spider 7 VAV type controller, again, a high-speed controller, but also has a built-in actuator and T1L. And then over to the right, you have the optimizer controller and this suite of controllers there that also does T1L. The main difference between these three, they're all IP based. They're all very fast, all have multiple communication methods, but the Spider 7 VAV in the center and the optimizer on the right have the T1L capability. That's the reuse of existing two-wire circuits. So those are the ones, if you want to use T1L or reuse, those are the ones you want to go with. The three sensors we talked about were the TR50 indoor IAQ sensors. That's the multi-sensor, 3-in-1 or 5-in-1 flavors. In the middle, you've got your standard CO2 sensor with the number and the red dot. And then we have a TR42 room sensor. That's just your typical single power data connected controller, temperature and humidity, dew point calculation, so on and so forth. You can see the specs there, but eventually there's three different flavors depending on how granular you want to get with your system, multi-sensor or single sensor. You have those two. Talked about the TC500 thermostat. Again, intuitive touchscreen, 3 air handlers, three heating, 3 cooling coils, master mobile app, contractor app, scalable control, Delta T, integrates with an internal and or external economizer as well. And there we go. Do we have any questions at this point?
Joe, thanks a lot. That was a lot of information.
Yes.
When I saw the slides going in, I was like, I don't know if we're going to get this in the hour, but you did it and really kind of explained it out really, really well. At this point, again, I encourage the audience to ask any questions or any thoughts for Joe. And in the meantime, we also have a couple questions for you, the audience. So Chris, if you could pull up those poll questions so we can kind of get an idea of where our audience sits. Do you have a potential application in the next 6 months that would be suitable for a Honeywell solution that we just went over here today? So if you can click one of those options there below, and we'll give you a couple seconds to do that. And I do have a couple questions for you too, Joe.
Okay.
Going through once we get through these polls, we'll give these give the folks a couple other seconds, and we'll ask that second question. Yeah, it sounds like you've given that presentation before.
I have. Yeah, I got it down.
And so now poll question number 2 for the audience. So if you do have a potential application in the next 6 months, what is the expected opportunity in units? And here's a super ignorant question here, Joe. And when you're talking about units, you're talking about structures?
Yeah, or that's what I would say. Just a number of buildings, structure could be a little outbuilding, could be main structure, but yeah, that's what I would consider it. Yeah.
Okay. Great. So while our audience finishes up answering those questions, one of the things that struck me when you were talking about education structures versus maybe other industries, I've been in a few schools. I'm up here in the Northeast, especially, where you'll have buildings with knob and tube wiring in some cases, right?
Yeah.
How, when you talk about legacy systems, how far are we going back here that you'd be able to enable to integrate those?
Well, I have seen it where they've integrated as far back as pneumatics in some cases. If they're communicating via that standard method, you can integrate pneumatics. It's not the norm, but in some of the East Coast cities, because the buildings were built a lot earlier than the West Coast, so to speak, you do see a lot of that. I know the average commercial building, I think in the East Coast, is around 77 years old, believe it or not. Yeah. In general. And so the key thing about the Niagara system and our contractor partners is the fact that they will be able to go and look at a system and give you the best possible way to do that. So in other words, you have several Niagara certified contractors who are certified to go in and look at that. Okay, I've got pneumatics here, I've got BACnet here, I've got 20-year-old system here. And so when you put the Niagara system in place to kind of pick up all the pieces, that is probably the best way to get started, is where are you now and what will it be? A lot of customers, they feel like they're climbing Mount Everest. Well, I've got this old system here, I want to get to here. Is it really that tough? No, it is not that tough. Every system is different, of course, but with the advent and the introduction of the T1L, being able to reuse the existing 2-wire and get the 10 megabit, that's a huge step forward in addition to all the IO modules. So the short story is, get evaluated, look to see what you have, and tell us where you want to go, and let us help you get there. And we know how to have the people and the power and the muscle to go and help and do that.
Yeah. So what is the best way to really integrate? You talked at one level about, you have the HVAC on one, security on another, fire on a third.
Yeah.
But none of them are speaking to each other. it seems that the Niagara is the ultimate hub here. Is that a way to
Correct,
describe it?
correct. Niagara is the ultimate way to do that. You go in there and it's an umbrella system. So it's the overarching master control system of that particular thing. So if I've got system X is security, I've got system B is elevator, I got system C is your HVAC, and they're none of them talking to each other. They've all got different logins. This is the way to do that. And the other thing you can do is you can also make Niagara profiles, Niagara logins. To each person have separate logins. In other words, I'm going to give this person access to elevator. This person's getting HVAC. This person's getting security. And then you can have a master control system managers, so to speak, that can have access over everything. And again, remember, you're also building in your cybersecurity. Not only are you going to get cybersecurity either with the Niagara, you're also going to probably get secondary security on the Six Schools IT system. They'll have probably some kind of a Windows server or something like that. They'll have access control lists built in or other security as well. But when you have a system that's on Niagara, it's downstream of Niagara, we have the cybersecurity there as well.
Okay, and when you're talking about the cybersecurity, that's the actual protection of the systems, right? I mean that is
Correct.
independent of any IT or data cybersecurity. Are there elements where those are tied in as well, or do those usually stay in separate worlds?
Typically, if you're going to, when we connect to the IT systems, we are downstream of the IT systems. In other words, you go into a building, you're going to hit the IT server first, and then you're probably going to hit us next, meaning the building control systems, if they set it up that way. You can have it set up separately where you have it coming into the building and directly connect to the HVAC. I see it done about 50% of the time. You'll have the IT and OT is us, operational technology, merged together under one system, or I haven't seen them separate as well. It really depends. But either way you choose to do it, we have the security built in. But typically, most of the time, it'll be IT first, then it'll hit us. Not always, but
Okay.
most of the time. Yeah.
And in some of your schematics too, we were looking at the building level, and then we asked the audience about how many units and how many different structures. Is there a layer between when we're talking about implementing this integration to a single building versus, say, an entire district or a portion of a district?
Yeah, what you would do in that case, if you're doing multiple buildings, you're going to have each building is going to have some kind of a gateway that gets to the internet. So let's say it's going to be school board X, okay, or let's just say New York City school system. They've probably got hundreds of schools, I would imagine.
Oh,
Take a particular borough. I've got the Bronx, okay, and I want to have all the different Bronx schools under one system. And so what you can do is you can set permissions. So you can give one person access to all of the schools that are connected because they're all connected via cloud to the cloud system, and then they're all connected. I can look at all my systems at once in the form of a map, and I can click on each one. Or I can give, a person at school A, you're only going to get access to this particular school. And you can set it up with login and password. And please make your password good. I have a slide that I do. It wasn't on this slide, where there's like the top 30 passwords in the world. And you would not believe some of the passwords people use. Some people use the word password as their password. But please make sure the password is good. You're only, because no matter how much cybersecurity you have, if it's a bad password, I can't help you. So
right,
be
right.
aware of that.
Yeah, 100%. Now, there might be some folks who are on this, we're talking about some sophisticated stuff. And also just when you talk about New York City schools, maybe they're a small district in Jersey, or maybe even a single structure.
Uh-huh.
Are there any differences when it comes to the scale of the use of these integrations?
It depends on the number of points. Yes, you want to use a controller that's going to be able to handle the system and in scale to meet a larger growth, depending on the growth. In most cases, one of the optimizer controllers is going to have enough points to do that. And when you add points to the system, there is a cost structure for the licensing. But in most cases, you get so many points to begin with, you can do that. Now, if you're going to talk about the remote building manager that we have, there is a different cost structure scaling depending on the size of implementation you want. And so when you pay that money to get the whatever size system it is, a lot of times the savings that you reap in the form of energy savings and being able to remote monitor pays for itself relatively quickly. I can't make any promises on how much you're going to save, but in general, most of the time you're going to yield energy savings and or just maintenance savings as well.
Yeah.
Did that answer your question?
Yeah, absolutely.
Okay. Okay.
When we're talking about the technology side of this, there's also the human side of it too. When it comes to probably, again, public education, K-12, there's some politics
Sure.
involved. There's school boards involved.
Uh-huh.
From your experience working with schools, what are some of the biggest challenges on that side of things in terms of making the case for integrating all of these things?
Biggest challenge is the cost. Obviously, educational facilities are very cost conscious, very cost focused. And so I know the ESSER funds are almost not run out, but they've all been allocated at this point. And so they had money with the form of ESSER funds recently, but now the most important thing is cost. And so what I would say to those people who are trying to upgrade, but cost is becoming an issue, is really take a look at the T1L, the capability that we have. If you have an ability to not place cable in a lot of places, there's going to be it's going to bump your project into a new cost structure. In other words, you're going to be able to lower the cost. I don't know what percentage would be. Everything is different, of course, but it really gives you that ability. And so the number one concern always has been cost. And then, of course, the other thing too is longevity. Obviously, we're Honeywell. We've been around for a long time. We're not going anywhere soon. So when you go in with Honeywell or with our system, you're getting the open system in Niagara. You're getting the multiple flexibility, multiple contractors. There's another cost savings, by the way. I put a Niagara system in place. I don't like what contractor X is doing for me. I get another bid from another contractor, and they may be able to cut me a better deal and give me better service. So yeah, by far, cost is definitely been the most concern.
Gotcha. What about in terms of the integration process? I mean, I could imagine that some of this might seem overwhelming to some of the folks who are on the call here today.
Uh-huh.
Is there a way to do this incrementally, or is it something, is it an all or nothing situation, or are there varieties in between?
No, there's all sorts of ways you can do it. You can have go in there, you can put an Niagara system in place and say, okay, this year or this first 3 months, we're going to bring our HVAC in. And then while you're getting that and getting all set up, you can say, okay, then we're going to bring in our security next. So you don't have to go in and do a complete rework. Niagara is very flexible and very scalable. And so maybe this year I want to do a test at one school, pilot school A. I'm going to do the school and start here. Oh no, that worked great. Let's go to school 2, 3, and 4 next year. And each time you bring it in, you can scale and bring it up. And so that's the other benefit is, number one, you get the benefit of the flexibility of Niagara with all the different systems. Our competitors have Niagara systems, believe it or not. So that is key. Look at a very slow, you can just, first thing you want to do is get that kind of controller Niagara system in place. Then you can go from there and you can add as you can go. It's very simple to do as you move forward. But make sure you get involved with one of our contractors to help you walk through that process, because it's key to have their guidance and our guidance as well.
Right, because I mean, these districts and these schools already have multiple contractors in place for each of these systems, I'm assuming, right?
Correct.
Are those partners all equally adept in terms of using your systems? I mean, are they already kind of accustomed to them, or what is that development process like?
What that we have, so what we do is with our partner contractors, we have Niagara certified contractors. They go to a school, they go through testing, they go and they learn how to use and operate Niagara itself. Not every contractor is going to be Niagara certified. So obviously you don't want, if you want to put a Niagara system in place, you don't want to call a non-Niagara certified contractor. But we put them through the paces and get them certified so they know what they're doing and they know how to use the Niagara system as best they can. And they are very good at what they do, especially like larger cities, especially New York, really, really good at what they do. Absolutely.
Yeah. So in terms of timelines, I would say folks are, you asked the audience if they're thinking about something in the next 6 months. Say they are,
Okay.
and they're looking at something. What is the average kind of a time span it takes to go from idea and first conversations to where something is actually up in place and running?
Well, let's see. Obviously, it's going to vary from school to school, but let me give you a reasonable answer on that. So it depends on the size of school, of course. I have seen them do it in as fast as a couple of months in some cases, and I've seen them take them 6 months. So the larger the school, the larger the implementation, the larger the upgrade that they want to do, the more time it's going to take. But if you have a customer that says, "Oh, I gotta have this done in 2 months, 3 months before the cutoff of the fiscal year," so on and so forth, that's where the contractor will step in and take a look at the system and give them a reasonable answer and say, "Look, your system is here. 3 months. Yeah, we can get you there at that point." So it really depends on the age of the system, but in general, they can do a pretty quick turnaround depending on the customer needs, and it may cost them more money to do for a faster implementation. Unfortunately, that it just depends on the speed they want to do it. But in general, it's pretty quick turnaround once they get the system in place.
How about in terms of stakeholders when it comes to making the decisions to do these implementations?
Yeah.
Are there folks now that maybe 10 years ago would not have been involved in this conversation that now are involved in this conversation because of the integration and those different
Yeah,
aspects?
typically I've seen directors of maintenance, directors of operations for educational facilities. They were the ones that holding the strings in most cases, and a lot of times they still are. More and more, I'm seeing more school boards get involved. I am seeing more C-suite of districts getting involved. And the reason I think I see that is because the pandemic, because it's such an overarching overall strategy of these educational systems. Not that they don't trust their maintenance people, but when you're talking about having a certain amount of money in the form of ESSER or something else, they want the C-suite and they want the school board involved. What's the ultimate goal? Is it air quality? Is it implementation of a smart system? And then what's the future here? And so they do get involved. It's not that they don't involve the director level people, but in general, I'm seeing more and more C-suite get involved and boards getting involved as well in these decisions.
Yeah. And I see that we're starting to run out of time here a little bit, but maybe one final question.
Yeah.
What would be that first thing that you would recommend of someone coming away from this conversation? They were saying, look, these technologies look interesting. It looks like something that could improve. What would be the first action item that you would recommend someone do jumping off of this call?
First thing I would do is I would get a hold of a local Niagara contractor that can come take a look at your system and have to know what you're looking at. In other words, you don't know where you can go until you know where you are. There's always a path forward, but everyone is different. And so I would get with one of the Niagara contractors and say, hey, could you come out here and take a look at my system, see what they can do, see what they have, and see where they can go. That'd be the first step. And then for the most part, what they can do is they'll give you a reasonable answer. So look, it's going to be a 6-month project, approximately X dollars. Who knows what it will be? In a lot of cases, everyone's different again, but evaluation is key. Get that done first so you see where you are.
Great. Well, I do see that our time is just about up, so we're going to wrap things
Okay.
up here. Joe, I'd really like to thank you for a really informative presentation.
Thank
And
you,
I'd like to
Kevin.
thank the audience members for joining us as well. As a reminder, you'll get an email within the next few days that contains a link to this recording along with the slides. Thanks again for participating and have a great day.